make understanding of science more interesting and entertaining, Nehru Science Centre came into inception in the year 1977 at Mumbai. Today, Nehru Science Centre at Mumbai has many theme galleries. One such gallery is Our Technology Heritage. This gallery covers various technologies which have been developed in India. Early primitive man was a hunter and food gatherer. It was the easiest lifestyle since the procedures allowed more leisure. Human race of Stone Age left this stage and in Neolithic period turned to food production. This was the beginning of agriculture, which was the first technology developed by man. These agricultural produce required processing and storing facility before consumption. For this, man developed pots, and pottery was the next important milestone in human technologies. As man became more dependent on agriculture, the concept of organized community and settlement was developed. Among the 6 early civilizations which existed 5,000 to 7,000 years back, one of them was Harappa and Mohenjo-daro of Indus Valley civilization. During this period, pottery became an important industry. A shapely earthen pot is one of the characteristics of the Harappan civilization. Several specimens of such earthen pots have been found in excavations. Relics of earthen pots are the largest in number among the remains excavated at Harappan sites. The earthenware of those times consisted of plain as well as coloured pots. These pots were made on potter's wheels, which were decorated with designs in black and baked in kilns. The potters of ancient India were maintaining proper temperature and knew the techniques of baking in pottery. Even today, Indian village potters use similar techniques of ancient potters. The town of Harappa was known for its town planning. Some of the salient features of their town planning were 10-meter broad roads which ran from east to west and north to south, crossing each other at right angles. The human settlement or houses were built of baked bricks of unusual dimensions, that is 40 by 20 by 10 and 30 by 20 by 10. In other words, 4:2:1 and 3:2:1 proportion, respectively, with 2 bricks lying sideways and 1 placed lengthwise on the top. The entire town was well connected by underground drainage which was 1 meter deep. The town had its own freshwater supply, which was in the form of small wells. Each house had living rooms, bathroom and kitchen. Some were double and triple storied. Special care was taken to keep each house ventilated with a central space open to the sky. Citadel was a special area in the town, normally occupying the top of the hillock. Probably, the citadel was either for residence of the chief of the town or for ritualistic functions. The town planners at that time also took care of the security of the town, and the whole city was fortified with gateways. One of the architectural marvels of Mohenjo-daro is the Great Bath. This is 56 meters by 56 meters in dimension and had a tank which measured 12 meters by 7 meters and had a depth of 2.5 meters. There are steps leading down to the tank. To prevent seepage, the tank was built with baked bricks. To keep the water in the tank clean and hygienic, there were provisions for drainage and refilling these tanks. These features shows that the town planning was systematic and had an administrative system which laid down the rules of town management. As Indus Valley civilization was well developed in trade and industry, it is not surprising that the Harappans constructed the first tied dock of the world for berthing and servicing ships at the port town of Lothal, which is situated in Gujarat. The Indian boat-making technology and navigational skills also dates back to 3rd millennium BC and to the Harappan times. The ships made during this period were fully seaworthy. This has been established by old paintings and murals seen all across the country and also from the seals belonging to that period. With the development of dock and navigational facilities, trade became prevalent. This can be seen as cotton, in which the Egyptian mummies were wrapped, was produced in India. Greeks used the term sindum for cotton, and Babylonians called it Sindhu, indicating that cotton was from Sindh in Indus region. The famous figure of monk from Mohenjo-daro with shawl-like cover on left shoulder provides additional evidence of use of cloth. Many clay spindles used for preparing threads from cotton have been found in excavations. From the works of Joseph Needham and other scholars, it is now certain that cotton cultivation and also use of wormgary began in India with the cotton gin. During the Indus Valley civilization, both men and women dressed up well and wore ornaments. This is established as a great variety of their ornaments have been found in excavations and also seen on the statues excavated. A variety of ornaments such as rings, armlets, multi-stranded necklaces, pendants, bangles, waistbands were also used. The gold and bead necklaces and the other ornaments found are artistic in nature. Carnelian and agate stones were made into beads using unique heating, cutting, drilling and polishing techniques. Sometimes, several designs and patterns were etched on the carnelian beads. One of the earliest molding technology in the world is the lost wax technology. The famous statue of the dancing girl, molded during the Harappa civilization, shows the fineness of wax molding technology. This technology involves a process where the wax model of the desired sculpture is used as a pattern to prepare a mold with the outer shell made of sand, clay and plaster around the wax model. This mold is then heated to bake the outer shell and thus melting the wax to give an empty space of the shape of the sculpture to be made from the mold. The molten metal, which is mostly bronze, is poured into the mold and allowed to cool. After cooling, the shell is carefully broken to give raw bronze cast of the desired sculpture. This is then finished by chipping and polishing. Desired color can be obtained with the help of chemicals and other techniques. This process of lost wax casting is prevalent even today in different parts of the country. Metals have been used in India even before the Indus period. One of the earliest metals used by mankind was copper. From the excavations, it has been found that use of metals and alloys was prevalent during Indus Valley civilization, and the products made from copper were used for trade with other civilizations. Another important metal, iron, has been traced back by reconstruction of facilities of some of the ancient furnaces of India, such as the Naikund furnace, dating back to 700 BC. Since then, iron metallurgy had undergone a process of evolution, leading to the production of marvelous edifices like the Delhi Iron Pillar. This was made by joining the iron bloom through horizontal forge welding process, which is the metallurgical wonder of the world. It has withstood the tests of time without showing any visible signs of rusting for almost 1600 years. Zinc smelting in India dates back to 6th century BC. Zinc is the most difficult metal to be smelted. The crucial point in zinc metal extraction is maintaining proper temperature, as the temperature difference between melting and boiling point of zinc is very small. Indian zinc smelters could achieve this. They used reverse distillation process to extract metallic zinc. Ancient Indians were the first to produce metallic zinc on industrial scale. It is estimated that each of the furnace block could produce between 20 to 25 kgs of zinc metal per day. From the archaeological remains of the sites at Zawar, metallurgists say that approximately 60,000 tons of zinc was smelted at these sites. Like alloy of copper and zinc, Indians were first to produce steel, known as woods, derived from South Indian term ukku for steel. Woods steel is produced by adding high quality of pure iron along with charcoal, glass chips, green leaves, which are loaded in a crucible. Then the crucible is heated in a furnace to get a woods cake. This woods cake is further heated at precise temperature to minimize the formation of oxide scale during forging. The heat-treated woods cake is then forged and deformed slightly with hammer blows while it is still hot. After series of forging steps, Wood's steel cake is then converted into a weapon. The steel blade thus